Well, ladies and gentlemen, welcome back to another episode of the Fanatical Futurist. We are, of course, joined by the Fanatical Futurist himself, Mr. Matthew Griffin. Matthew, I know we've got a real treat in store for listeners today. We're going to be talking about robotics and all the craziness which revolves around that. But firstly, haven't spoken to you in a while. What have you been up to, sir? I'm guessing travelling to all four corners of the earth as always.
Well, not quite all four corners of the earth, but certainly over to Latin America, the Middle East especially. So I've spent over a week in Mexico. So I was working with the government over there on the future of different sectors and everything else. So that was actually kind of fun. So we ended up in Mexico City, but also down in Cancun. And I have to say, in Cancun, nice warm weather, but the pools are really cold. That's it. And
Really?
that's when
That's
we
annoying.
weren't actually working. Oh yeah, that's it. But yeah, but lovely weather. And I mean, if you ever go to Cancun, I mean, yeah, you can see flocks of frigate birds and all that sort of stuff. And they're spectacular. But then instantly flew over to Riyadh and ended up sitting down with a lot of government ministers as well as their excellencies. So we had their excellencies and we had their highnesses and HGs and HRs and everything else at these sort of sessions that we sort of conducted. And while I can't sort of say too much about what we're sort of doing there, you're going to end up seeing the outcome of the workshops that we did there really in about a year's time. Again, as I sort of travel between different countries and speak to different governments, but also businesses, but in this case, governments, it's just staggering to see the approach that different governments take to owning the future, if you kind of want to put it like that. When I was in Saudi Arabia, we were talking about the future of different sectors. Just the ease at which these ministers and these excellencies got things done was staggering. They would be talking about building huge complexes to do new things, and they just go, yeah, we've got the land over there, we've got the people aligned, but we're just going to build this stuff. And this is typically where, particularly in Riyadh, they're spending about $65 billion building stuff out. And, when you sort of start doing work with the UK government, so I've also been doing work with the UK Department of Work and Pensions, just the difference in attitude, vision, approach, is absolutely staggering, and then sort of when we actually have a look at the West, we wonder why we're actually struggling to keep up with some of these sort of more ambitious nations, like Singapore, for example, like South Korea. China is kind of the big elephant in the room and so on and so forth. It's been sort of a fascinating ride. Can't really say too much, unfortunately, because of all the contracts and everything else. But, come back in a year's time and you can see exactly what I've been up to. You're going to have to wait.
Well, that does sound incredibly exciting, Matthew, but obviously we are here today to look at the future of robotics. So why don't we start off by just explaining what is robotics in general?
So when we actually have a look at the field of robotics, certainly in this podcast, we're sort of going to angle ourselves more towards, robots in terms of, and I was going to say robots in terms of these sort of giant metal lumbering hulks, basically, that we sort of talk about and see in science fiction films. But actually, as you'll sort of find out as we sort of step through the next, sort of half an hour or so, that's definitely not the case. There's a lot more basically to non-RPA robotics than first meets the eye. And that's both scary, exciting, and it's a really deep wormhole that we can go down.
Well, talking scary, Matthew, why don't you scare us with some robotic facts or something shocking to start us off?
Yeah, all right, okay. So I suppose, let's start here because, when I'm doing my keynotes and things, there are actually quite a lot of people that say, so, Terminator, real, not real, okay? So we might as well actually just step down that particular rabbit hole. Now, when we have a look at the development of military robots or military robotic systems, on the one hand, basically, we've got organizations like Lockheed Martin that have already managed to develop what we call fully autonomous kill chains. Now, they've done this with drones, really, but ultimately we can start translating this into robots as well. So again, a little bit of a segue here. So with Lockheed, quite a while ago, basically, they managed to create a drone that is fully launchable from a submarine. The drone goes into the air. Drone then uses connectivity, artificial intelligence, machine vision, different sensing systems, et cetera, to identify targets and then take the targets out. Now, when you actually when you sort of step back in time again a little, for about a year ago, the United Nations concluded, but were very careful with their wording, that there was a Turkish drone, and the reason why I'm talking about drones is because this will segue into robots in a minute. The United Nations concluded that there was this fully autonomous drone that had been developed in Turkey that for a while lost connectivity. Now, when it lost connectivity, it was being used in the war in Syria. It still managed to identify targets and suspects and kill them. Now, what made this particularly interesting and sort of scary was the fact, basically, that essentially it was a autonomous hunter-killer drone, because it identified targets while not being connected to any central authority or managed by any central authority, and then took them out. So now when we start having a look at robots, there's a huge amount of robotic development in the military. And what always kind of gets me is, when you're speaking to admirals, generals, particularly sort of European and US admirals and generals, they say, yes, while we can actually produce fully autonomous hunter-killer robots like we see in Terminator, rest assured that there is always, and this is sort of what gets me, there is always going to be a human in the loop named Brian. And before we take a kill shot, or before the robot takes a kill shot, Brian will use his big human brain to figure out whether or not he should push the big red button in front of him and kill the target. Okay. Now, we all know, basically, that, in military circles, as soon as one military power starts to develop and then deploys a fully autonomous, should we say, Terminator-like robot in the field, that opens the floodgates. And then similarly, when we have a look at the United Nations, the United Nations have been trying to put mandates together to prevent robots being turned into fully autonomous weapons systems. And there are a lot of countries that are not signing up to those policies. So the United Kingdom, for example, Russia, obviously, the United States, China, and so on and so forth. So while we have these generals and admirals saying, we will never, ever produce a fully autonomous hunter-killer robot, there will always be this bloke called Brian who makes the final decision, why aren't they signing up to the treaties? Yeah, and they're not signing up to the treaties because ultimately they are generally all afraid that at some point another superpower is going to deploy and field a fully autonomous hunter-killer robot, and they want the flexibility to deploy their own. So anyway, now we've sort of got that out of the way. When we actually have a look at the Terminator, Terminator and Skynet kind of work in sync. Now, from a Skynet perspective, Skynet basically was this sort of big artificial intelligence in the movies that, if you remember, basically would actually look across the world and try to figure out different threats, and then try to figure out what those threats meant to both human survival, but also its own survival, particularly its own survival. Now, there is an artificial intelligence that's being developed by the US Bleeding Edge Military Research Department called DARPA. And this particular artificial intelligence is exclusively designed to scan the world, basically, for risks and threats, and then try to figure out what does that all mean. Okay, so we've got this system that is being developed. They reckon it's going to take about a decade because it's a very large project. But we've got this system that's being developed that essentially is part of that Skynet. Now, when we actually have a look at what Skynet also managed to do, Skynet also managed to take over control of a lot of the US military's military installations and weapon systems. Now, about 3 years ago, again, DARPA was running what we call capture the flag competitions. And these capture the flag competitions were exclusively targeted at trying to create artificial intelligences that were both capable of identifying vulnerabilities within enemy systems and then either exploiting them, or identifying vulnerabilities in a friendly cyber system and then patching it. Now, about 2 years ago, the US military actually deployed one called Mayhem into its critical operations. You can look at this online and everything else. It's a lovely conspiracy theory, sort of, waiting to rise its head. But actually, the Pentagon went on record, which is always sort of strange, and said, yep, we've taken this platform called Mayhem and we've shoved it into our critical systems. Now, Mayhem was actually one of these artificial intelligence robot hackers that is designed to identify and either fix or exploit vulnerabilities basically within the Pentagon's cyber operations systems. Now, in addition to that, when we actually have a look across the pond, have a look at Russia. Russia for decades has been talking about its dead hand artificial intelligence. Now, no one really knows whether it exists or not, but they are generally suspicious and generally think that it does. The Russian artificial intelligence dead hand system is an AI which has been developed over the past couple of decades that essentially listens out for signals traffic. Yes. So if this artificial intelligence hears chatter between the Russian high command and the Russian government, then it kind of figures that the Russian government hasn't been wiped out by a nuclear bomb. However, if it doesn't detect signals traffic for a particular period of time, allegedly it has autonomy to then start launching Russia's nuclear arsenal. When we look at when we start talking about the future of Terminator, we kind of have the brain being developed and the ability to act that is being developed. Now, when we talk about the actual robots themselves, this is sort of where we get into some fun. Again, if you kind of remember, Skynet actually took over the manufacturing facilities of Earth to both design and then manufacture its robot Terminator army. Now, about 3 years ago, the University of Oslo, probably one of the last places you would actually expect this to happen, managed to get a generative artificial intelligence, which is kind of related to the likes of ChatGPT that we see today, but it's like a distant cousin. It doesn't do text prompts. It does something different. But in their case, their generative artificial intelligence would actually design a robot and then send it to a 3D printer, and it would then be assembled, and then the robot would go off and do whatever it wanted to do. Or whatever it was designed to do. Now, this one would just sort of move around a building. However, MIT a little while ago demonstrated that you could 4D print a robot. Now, when you 4D print a robot, the robot doesn't need assembling by a human person. 4D printing is rather unique in that it brings in new materials and it brings in time as the fourth element. And these robots can be 4D printed and then they walk off the printer themselves. Okay, so from a manufacturing and design capacity, we've actually got those already here, and they're actually sort of getting better and better. OpenAI, just again, a little bit of a segue, but it's relevant. OpenAI, who created ChatGPT about 2 years ago, got hold of what we call the dactyl robotic hand. It is literally just a robot hand. Now, what they did is they actually used generative artificial intelligence and virtual reality and simulation training to create the world's most dexterous robotic hand. Now, this robotic hand was developed by cramming over 800 years worth of training into just a couple of days, all in simulation. But the reason why I'm mentioning this is because this robot hand can solve a Rubik's Cube in a minute, one-handed. It's that dexterous, So when we actually when we start thinking about creating some sort of more advanced, robotic systems that can start being on a par basically with the Terminator, we've got generative artificial intelligences that are creating some really interesting robotic capabilities. In addition to that, we've also got other generative artificial intelligences that are creating what we call evolutionary robots. Now, these evolutionary robots do exactly what they say on the tin. So by combining the code from two robots together, a little bit like we do with human DNA, these robots actually are able to combine their digital code to create really a fundamentally different kind of robot. Now, again, when we have a look at these are sort of coming through in Europe. When we have a look at the field of what we call evolutionary robotics, we do increasingly have robots that are able to design themselves, but then also combine their own code to evolve new characteristics and properties that are representative of both of their hosts. When we actually have a look at that, we now have a Terminator robot that can start evolving. But as many people probably remember, the Terminator robot had human skin over a metal endoskeleton. And the University of Oxford, again, you wouldn't necessarily expect it to come from them, a little while ago, 3D printed human skin. It was designed for skin grafts for burns patients. But when you 3D print human skin, it's generally inflexible. So what they ended up doing is they ended up putting that 3D printed human skin onto a robot. And the robot would flex its hands, its elbows, and its joints, basically to essentially make the 3D printed human skin more supple, so that it would actually be a better graft for burns patients. Now that is human skin over a metal endoskeleton. And then when we start talking about traditional robots, because, when we have a look at the original Terminator, the Arnold Schwarzenegger Terminator, it was kind of a traditional robot. We've got the Atlas robot from Boston Dynamics, which is one of the most sophisticated humanoid robots of all time. And while it doesn't necessarily have full autonomy, and while it does still need an element of programming, it's a very good adaptation of that Terminator robot, and in fact, I think Boston Dynamics have been getting a bit miffed because when we talk about Boston Dynamics robots, people have been putting guns on them, like their robot dog and everything else. So we are starting to see the weaponization of these humanoid robots. And again, Russia about a year ago fielded a video of essentially the Atlas robot, basically with a fully automatic machine gun, which then brings us into the territory of robot soldiers. And when we look at robot soldiers, again, about sort of a year ago, the US military publicly started training its troops to actually combat what they saw the rise of military robots. So again, if you go online, you can actually see a lot of US Marines going through woods trying to figure out, how they actually take out these increasingly sophisticated drones, but also these increasingly sophisticated robots, which take the form of everything from sort of robotic cargo dogs to fully semi-autonomous humanoid robots. That's really freaky to see. Because
I'm pretty sure I saw the Chinese army with a robotic dog. And also, were they not using robots to enforce lockdown, sort of going around the streets and making sure that...
absolutely. So you had the robotic dogs in their case, you actually sort of going through different parts of, Shanghai and Beijing, just to sort of see, if anyone was actually out and about and everything else. It was also then reinforced with drones. So, when we have a look at the future of, say, for example, military warfare, it's very much a combination of robotic systems, not always just robots, but robotic systems and drones. You end up in this sort of space where Terminator is increasingly real. No one's actually put a full one together yet. No one's actually joined all these systems up yet, but they could if they wanted to. But then when we actually have a look at things like the T-1000, the shape-shifting robot, we've got NASA that's created some rather basic shape-shifting robots. And NASA have even created some ice robots. And these ice robots are designed to explore interplanetary sort of exoplanets and so on and so forth. But they actually self-heal. So these ice robots will start falling apart or whatever it happens to be, but they've got the ability to change their shape and then heal because they're made out of ice. But over in China, if we have a look more specifically at the T-1000, there's this really interesting sort of element called gallium. Now, gallium is solid at room temperature, but if you heat it up a little bit, basically it becomes a liquid. And then if you apply magnetism and all that sort of stuff, it becomes a fully polymorphic robot. Now, for anyone that remembers the T-1000, the T-1000 was this polymorphic liquid metal robot that could shapeshift. And in one particular case, it would actually escape a prison cell because it just oozed through the bars. And about 2 months ago, we actually saw the development of really the third generation of polymorphic liquid metal robots. They don't have intelligence in them yet, but we can come on to that thanks to Carnegie Mellon. This liquid metal robot, it was the size of a Lego man, ended up doing exactly what the T-1000 did in the Terminator movies. It ended up escaping from a prison cell by oozing through the bars, but then reforming on the other side of the bars. Yeah. So as I say, when we start having a look at the future of sort of slightly scary robotics, it's on the one hand, I think, both fascinating, but also freaky. Particularly when in the back of my head I'm seeing all these different things being developed and thinking, hey, that's really cool. There's some great applications of a polymorphic liquid metal robot, etc. But what happens basically when some frankly idiot basically weaponizes these things and really goes to town on trying to weaponize these things?
I wanted to get your thoughts on domestic robots as well. I saw a stat that 40% of domestic chores will be done by robots in 10 years' time. But can you just tell us how progressive everything is right now? I mean, obviously, people are probably unaware of how much already robots are doing behind the scenes. But can you tell us in 5-10 years' time what our life will look like?
In 2069, it's going to be Samsung's 100th birthday. So Samsung sort of brought me in basically to have conversations with them about what life in 2069 could actually look like. And we put together a report basically called the KX50 report, which again, you can see online and you can sort of, move through, etc. And one of the things basically that Samsung identified through its consumer research when they went out to lots of people and said, what's of all of the different things that Samsung could create and produce, what's the thing that you want to see us develop the most? And actually about 60% of people said we want a robot that can do all of our housework, the ironing, lay the table, the dishwasher and all that kind of stuff. So, so Samsung sort of went off and did some stuff behind the scenes. Now, it says 2021, Samsung actually unveiled their first domestic robot. Now, it would cost about $5,000. They aren't selling them yet. But this domestic robot, again, uses a combination of artificial intelligence and machine vision. It's been trained in a very specific way. Now, when we think about artificial intelligence, we think artificial narrow intelligence, where narrow AI basically is very good at doing one thing, like loading the dishwasher, but it can't lay a table. And narrow AI applies to everything, and it's very good at maths, but it sucks at physics, whatever it happens to be. So we have this increasingly common concept of what we call generalized artificial intelligence, not to be confused with general artificial intelligence, which is where AI exceeds the capabilities of humans. But generalized artificial intelligence are AIs basically that can do multiple different things. Now, in Samsung's case, their generalized artificial intelligence, which is packed into a hybrid robot brain, chip in its head, basically, is able to do loads and loads of different things. So if you're sitting on a sofa, it can go to the fridge and it can get you out a can of beer and it can bring it to you. It can tidy the table. It can lay the table. It can load the dishwasher. It can vacuum the floors. Basically, it can clean the sides. It can tidy away and fold the laundry, all that kind of stuff. So, that's sort of kind of a fun thing. But again, sort of when we actually talk about where we'll be in the next 10 years' time, the fact of the matter is, if you have a look just, for example, at robot vacuum cleaners, the majority of people don't have a robot vacuum cleaner, despite the fact that they cost about 300 quid. You just sort of plug them in and, you go out and then they vacuum your floor. And this leads us to kind of this. Today, basically, we've got the technology and tools that allow us to create these relatively advanced robots like Samsung's, robot. But the reason why we don't see these things in homes is because people don't necessarily trust them, or there's a cultural barrier, or they're too expensive, or whatever it happens to be. So what we see from a cultural perspective is, once we've developed something along the lines of the Samsung home robot, when Samsung starts selling it, it'll still take about 10 to 20 years before these things become commonplace, not necessarily even ubiquitous, simply because as humans, we sort of go, oh, brand new shiny thing, but I will wait a very long time to buy the brand new shiny thing. Yeah, I mean, some of the breakthroughs that we're actually seeing into what we call generalized robots, especially with things like the Google Everyday Robot project, where these robots basically will actually sort out different things around the home. They'll take the trash out, they will sort your trash for you as well, etc., etc. MIT have got some very exciting programs as well, basically on that front. We already have a lot of the technologies that we need to help us really eliminate probably about 80% of household chores, tidy the kids' bedrooms, etc., etc. But it's going to be a very long time before most people, or even a decent majority of people, actually have a robot at home tidying the kid's bedroom, even though you actually probably want to buy one now.
We're talking about elimination. The other eliminating factor is robots are eliminating jobs. They're obviously going to increase economic growth and produce new opportunities. But what is the impact going to be in the short term, in the next 10 years, let's say, following on from that strand, on jobs?
Yeah, so this is where, when we actually have a look at the impact of of robotics basically on jobs, you've got robotic process automation, which is software. You've got just general automation itself in the terms of sort of cognitive artificial intelligence. Generative artificial intelligence is a little bit like ChatGPT, which has the potential to disrupt about a billion jobs and about $20 trillion worth of GDP. But if we sort of stay away basically from kind of the software-based robotic systems, that are actually emerging, and have a look at traditional robots, about 2 years ago, Amazon managed to develop a very dexterous and very fast picking robot. Now, one of the biggest problems that companies like Amazon have had when it comes to bringing robots basically into the warehouse is, robots are very good at sort of, lifting loads and moving about the warehouses and all that kind of stuff. But frankly, human workers basically are still by far, or were still by far, the best way to get goods picked. So in the Amazon warehouses, you'll receive these bins of products, and you'll pick out the Lego bricks and it's got to go into that basket, and you'll pick out a carrot and it's got to go into that basket over there, and you'll pick up some jeans and it's got to go into another basket over there. Humans, basically up until about a year ago, were still the fastest and best and cheapest way to actually do that, do that sort of that picking function. But we now have robots basically that are able to identify millions of different objects almost instantaneously, and then have the dexterity, sort of typically the hands, the grips, et cetera, to actually pick those particular products up and then put them into different baskets and bits and bobs. So when we actually have a look at sort of traditional robotics, we can already easily see how within the next 10 years, Amazon, even by its own admission, will be able to create what we call dark warehouses, where there are no people involved and there are no people overseeing these systems. Now, the reason why Amazon say that it's going to take them up to about 10 years to develop a fully dark warehouse is simply because they've got millions and millions of different types of products. Now, as we start having a look basically at some of the other functions, when we start talking about replacing humans in particularly manufacturing settings, we're seeing robots now that are fantastic at sewing. Now, a silly little stat, but an important stat on that particular one, is these robots basically that can sew your clothes just as well as a human seamstress can, actually displace about 200 million jobs, especially in Asia, where we have a lot of sort of clothing, manufacturing centers. But one of the sort of the oddest stats for me, basically, that I sort of discovered about 8 months ago was a robot that can sew and stitch together clothing and all that kind of stuff could actually end up putting over 160 million child workers out of work, bearing in mind that children aren't really supposed to be in a lot of these manufacturing centers anyway. So that was a weird one. We saw that actually come out from a number of charities that sort of started putting the sums together. But then when we start sort of moving up the stack, when we have a look at companies like Foxconn basically make, all your iPhones, all your gadgets, they're making cars and everything else now, et cetera, et cetera. Foxconn have created essentially sort of hybridized, kind of generalized robots that can quite quickly move from doing one thing to another. So anyone in manufacturing will know that once you've trained your robot to do one thing, for example, lift a piece of sheet metal and put it onto a car, it's very difficult and very expensive to retrain that robot to, for example, put together a phone or whatever it happens to be. So robots generally have been very inflexible when it comes to moving between different tasks and functions. However, again, really kickstarted by Foxconn and Google, now basically we have the development of robots that can retrain themselves. So we've even got the development of robots courtesy of MIT, like the Baxter robot, where if I want to train the robot to do a new task, I put on a brain machine interface. I think about the task I want the robot to do. So, it could be anything, whatever it happens to be. And telepathically, I train the robot, and the robot can now do whatever that task happens to be. Now, in addition to that, when we start having a look at some of the Google and Foxconn projects, by combining robots, so actual, metal chunky robots, with artificial intelligence in the cloud, I can now teach one robot to do something new, like open a door. But that robot is essentially connected to every other robot, essentially via a hive mind. So that single robot can now teach all of the other robots that new skill instantly. So when it comes to repurposing robots in the factory, when it comes to helping them move from doing one thing to doing something completely different, the training cost is now almost zero. The time that it takes us to do it is almost zero. The effort and resources involved are almost zero, which means that increasingly when we think about Industry 4.0, we will see more robots actually taking more human jobs because they are much, much easier to retrain. So there's this whole strand of, should we say, robotic technology developments that are actually happening now that a lot of people actually don't see, don't even necessarily think about. Slowly but surely, all these different technologies and these different innovations and breakthroughs are getting better and better and better, even down to the point when now we're starting to see the development of robots that are self-aware. So when we have a look at the manufacturing setting and we talk about cobots, where, for example, we tag team a human with a robot, for example, in a car manufacturing or car factory to do things. Increasingly, we're now starting to imbue robots with artificial robotic skin. So if they accidentally hit the human worker, the robots actually feel pain. We're also starting to see the development of self-aware robots that are not just aware of themselves, but also aware of the concept of time, because the concept of time is a sort of uniquely human kind of or biological trait. Robots don't have a sense of time. So when we have a look at the development of robots that are self-aware, there's a lot of stuff happening there. And then this sort of moves me on to this one. A lot of people wonder when we will get conscious robots. Now, for anyone that's actually read my Emerging Technology Codex, which you can download from the site, you might have picked up in the robotics section a technology called neurobiotics. So that's neuro is in neurology, brain, that sort of stuff. Again, when we actually have a look over the pond, basically to those crazy Americans, we're actually seeing DARPA, as well as other organizations, create some of the world's first conscious robots. And people sort of might wonder how we actually do that. Now, there's kind of two ways that we can do it. Firstly, we've got organizations that have actually digitized biological brains and then put them into Lego robots, and those Lego robots will go off and do different things. But it's estimated that these robots with digitized biological brains actually have a sense of consciousness because of the way that they react to different stimuli and all that kind of stuff. But if we want to talk about real robots with real consciousness, then DARPA has a fun little project that they've been dabbling about with for years, and this is Neurobotics. And this is where you take worm brains and all these, and dragonfly brains, and you put those brains into the bodies of robots. So even though we are using insect brains in robots at the moment, they are still classified as actually conscious robots. They're kind of like this cyborg mashup. In the case of dragonfly brains, when you put a dragonfly brain into a robot, that robot gets very, very good at, ironically, missile defense, because dragonflies are one of the very, very few creatures that are able to predict where their prey is going next, which is very handy in missile defense. So a lot of I've sort of got to stress, basically, a lot of the robots, the conscious robots that are being created at the moment are really small scale. But, when you have a look at, again, the sort of military applications, there are some interesting and weird things going on. But again, when you have a look at DARPA, for example, and I've got to put this in simply because, again, it sounds crazy, but, this takes us into the convergence of quite a lot of different technologies. DARPA have been recruiting lots of human gamers to train their robot swarms in battlefield simulations. And the reason for that is, if you have a look at people who play Call of Duty, for example, or these first-person shooters, as an e-gamer, you are trying to figure out the best strategy to use to take out your enemy, your opponent, basically, in these gaming environments. So DARPA has been putting brain-machine interface hats, helmets, whatever, onto gamers' heads, recording their brainwaves, and then telepathically, I say telepathically, we're sort of using human brainwaves to train robots and robot swarms and robot systems, a little bit like the MIT Baxter robot. In this particular case, DARPA are actually using the brainwaves of human gamers to help them train robot swarms and help those swarms develop better battlefield strategies, which again is, something you can't really make up. But again, it just shows the power of what happens when you start combining different technologies together. So it's quite interesting to start seeing the convergence of, for example, brain-machine interfaces and essentially human telepathic capabilities, basically, with the training and development of robots that at some point might end up killing us all. Back round to the Terminator.
Of course, always back round to the Terminator. But before we finish off, Matthew, I know you're a big fan of hive minds in robots, and obviously they're now at a point where they can self-heal. They don't need the human aid anymore. But what can the humans learn from the hive mind mentality?
Humans can already have a hive mind. So the technologies that we've actually used to create robotic hive minds are actually they're being adapted. I'll sort of use that. We're very and this is at a very basic level, being adapted so that we can actually create human hive minds. So there's a particular program called BrainNet, and essentially using, again, skull caps, so brain-machine interface skull caps. We've already put people together to share telepathic thoughts. So if you think about the Borg in Star Trek, I was going to say Star Wars, but if you think about that'd be wrong. But if you think about the Borg in Star Trek, they kind of have this hive mind mentality where they all kind of not necessarily think the same thing, but they can all share the same thoughts and brain and all that kind of bits and bobs. We're already breaking down those barriers. And organizations like sort of Harvard, MIT, University College of London, there are quite a lot of organizations and universities that are actually sort of, really pushing beyond the bleeding edge on this. So we can see a point in time where humans can, if they wanted to, if we wanted to, actually share a hive mind construct. But from a learning perspective, we've already seen the use of artificial intelligence, again, courtesy of the US military as well as China, being used to help upload knowledge to people's minds, which I think we've sort of spoken about in previous podcasts. Because the human brain is plastic. Just as I'm sort of talking and people are absorbing knowledge, what we've managed to do, and we managed to do this sort of really 4 or 5 years ago now, is simply find a way to telepathically train people, and whether this is kind of neuro training, neuroscience, et cetera, that's a whole conversation really on the future of education, which maybe we should talk about in the future. So there's a lot basically that humans can actually learn from robots. I'll sort of put that carefully, but there's a lot that we can also adapt basically from sort of the world of robotic technology to actually benefit ourselves, and that's before we get anywhere near things like androids, cyborgs, and all these kind of other things that we're again seeing the sort of the early developments of. When we sort of think about robots, a lot of people will probably still be thinking about, the big metal hulking robot, that's chasing you down the street or carrying your shopping or whatever it happens to be, or both. Maybe if you've gone to the shops and you're sprinting back home. When we actually have a look at the future of robotics, you've also got to think a lot smaller, and you've also got to think laterally. So we've converted biological organisms into robots. So these are called xenobots. A little while ago, basically, a couple of universities took frog stem cells. They managed to program them and then managed to create really the first living programmable robots. Now, when I talk about these robots, there's nothing metal or artificial about these robots. They are purely organic. But these xenobot robots are capable of doing basic tasks. They can be programmed, and surprisingly, which might worry people, they manage to replicate.
Oh, good.
So we've sort of got, so we've got xenobots is a really sort of fascinating area. We've got biohybrid robots, which are a combination of inorganic and organic materials. So when we look at biohybrid robots, we've managed to turn algae into biohybrid robots, and these things can go off and detect pollution and do sensing tasks and duties and everything else. We've also got DNA and molecular robots. Now, a DNA robot is a robot that is made out of DNA that can do things kind of at the nanoscale, pick up molecules and do different tasks. This edges us closer to things like nanobots, nano machines. But in the case of things like molecular robots, a little while ago, we managed to create a set of molecular-sized robots. So just think of a regular robot that's just made out of molecules, and much, much smaller, obviously. We managed to put these molecular robots in a production line, and we managed to get them to create molecular-sized products. Now, from a future of manufacturing perspective, those are the first kind of generation 0.01 molecular assemblers. So, as I say, when we start having a look basically at this sort of field of robotics, it's not just these kind of hulking, metal robot dogs that are being used for last mile delivery, or humanoid robots that are being used for a variety of different purposes, et cetera, et cetera. They go much, much smaller than that. And even when we have a look at things like soft robotics, we've got robots that are actually made out of, for example, mammalian muscle cells that are able to perform different functions. We've even got crystal robots. I mentioned ice robots earlier, but we've also got crystal robots And these crystal robots are literally robots made out of crystals. You know, if you sort of think about, you know, amethysts and everything else, I'm talking literal crystals that are able to move and perform different tasks and functions and everything else. So really, you know, when we actually have a look at the future of robots and robotics, you know, the physical ones as opposed to the software and artificial intelligence and RPA based ones, not only is it fascinating, but there's a huge amount of research going on, even in the case of things like inflatable robots, where NASA, for example, again, has been working with a variety of different universities to create inflatable robots. And the idea behind these inflatable robots is, you know, just like a balloon, you ship them up into space, deflated, and which means that they take up very little space and so on and so forth. Once they're on the International Space Station, you inflate them, and then you get them to do tasks like, you know, taking panels off of the ISS or whatever it happens to be. But when we have a look at inflatable robots, the biggest problem that we have with inflatable robots is trying to control their movements, because, you know, they're generally kind of floppy and everything else. So this is where advanced sensing comes into play, advanced artificial intelligence comes into play. But you know, if you sort of have a look at the 311 Emerging Technology Codex, there's a section in there called Robotics, and all these are actually covered in a lot of detail in there. And then when we have a look at nanobots, you know, nanobots are traditionally made out of either organic, inorganic, or a combination of both materials. And when we have a look at nanobots, we've managed to create nanobot swarms about 3 years ago that are capable of very basic in vivo human surgery. So, you know, if you tear your gut, if you tear your gut or your intestine, these nanobots can swarm to the area, and there's some funky videos on it. Yeah. I mean, these are really basic. You know, you're not going to see these in healthcare for another 30 years, but they can actually repair that site. When we have a look at sort of similar kind of robots, we've got robots that are able to enter into the human body that are fitted out with 3D bioprinters. And these robots, I mean, they tend to look like endoscopes. And there aren't that many, but there are a few. They're able to go into the human body, identify soft tissue tears, and then 3D print, you know, soft tissue over the tear to repair it. So we've also got nanobots that are able to identify and then drill into and kill cancerous cells, which kind of starts taking us into an area that I sort of call hybrid immune systems, which is kind of a combination, a little bit of nanotech, but much more genetic engineering. So maybe we talk about that in the future.
Definitely.
It essentially turns the human body into a really almost an immortal instrument, you know, where these hybrid immune systems are able to identify disease and then kill it as soon as it appears, you know. So that's completely different topic. There's a lot more detail than that.
Yeah.
But, you know, we could have some fun with that in the future.
There's a lot. I mean, that was an incredible overview of just the amazing things and terrifying things which are going on in the world of robotics. Matthew, we thank you for your genius insights as always, and we wish you well on your travels. And we will see you again very shortly to be able to touch on all these other little subjects which you've flirted, you know, that we may be able to get involved with very soon. Thank you.
Yeah,
Matthew.
well, you take it easy. Cheers, Freddie. Take it easy, everyone.
Have a good one, mate. Speak to you soon.
Speak soon. Bye. Ta-da.